Okay, so in geometry today, we're looking at part 2 of section 2.4, the postulates and diagrams. Today, we're going to focus on what we can assume and not assume by looking at a diagram. We're going to review what we did yesterday. So postulate 5, again, if given 2 points, then exactly one line intersects them. Postulate 6, if given a line, then it contains at least 2 points. Postulate 7, if 2 lines intersect, then their intersection is a point. Postulate 8, if given 3 non-collinear points, then only one plane contains them. Postulate 9, if given a plane, then the plane contains at least 3 non-collinear points. Postulate 10, if given 2 points in a plane, then the line containing them lies in the plane. And postulate 11, if 2 planes intersect, then their intersection is a line. Okay? And again, the perpendicular figures. A line is perpendicular to a plane if and only if it is perpendicular to every line in the plane that intersects it at that point. So over here, now we're going to list a lot more today than what we did yesterday. Let's start out with line, let's see, BD. Okay, so line BD. We're going to list everything that line is perpendicular to. So line BD is perpendicular to which plane? So BD is in plane S, so it is perpendicular to plane T. And we can say that line BD is perpendicular to what other line? So line BD is perpendicular to line CE. Now let's go with the other line, CE. So we can say line CE is perpendicular to what plane? That is perpendicular to plane plane S. And then let's say line CE is perpendicular to what line? Line CE is perpendicular to line BD. And then we could say that line BD intersects line CE at point A. Okay, so again, this is just kind of a review of what we did yesterday. Using the diagram, write an example of the postulate. So letter A, postulate 8. Postulate 8 said if given 3 non-collinear points, then only one plane contains them. So in this picture, I need 3 non-collinear points. So if given points, so let's pick 3 points over here that are not on the same line. Again, I only have 3 points, A, B, and C. So if given points A, B, and C, then they lie in plane P. And again, this is just giving specific information of a diagram. So let's look at B. Postulate 5. Postulate 5 told us if given 2 points, exactly one line contains them. Exactly one line intersects them. So the only points I have on a line in this diagram are A and B. So if given points A and B, then line AB intersects them. And finally, postulate 11. Postulate 11 states if 2 planes intersect, their intersection is a line. So the 2 planes I have are plane P and plane Q. So if plane P and plane Q intersect, then they intersect at line M. So where the two intersect is that line right there. All right, so now today we're going to focus on what can we assume and what can we not assume by looking at a diagram. So this is the diagram down here that we're going to look at. We have plane F, then we have line CD, okay, that is going through that plane. We have line AB, which is lying inside the plane, and then we have all of these points. So first, let's talk about what we can assume by looking at this picture. So first, look at points A and B. We can assume that points A and B are collinear. So we can assume points A and B are collinear. We can always assume 2 points collinear because remember, we don't even have to look at a picture. We can assume that 2 points are collinear. Any 2 points are collinear. Okay. We can assume that line AB and line CD intersect at point B. So line AB, line CD intersect at point B. We can always assume vertical angles, right? So I would have vertical angles here. I would know that those are the same. I would know that these angles are the same. You can always assume vertical angles by their definition. We can always assume linear pairs. So I know that right here I would have a linear pair. We can always assume linear pair because, again, that is a definition. We can always assume supplementary angles add to 180 that are on a linear pair. So overall, we can assume collinear, right? We can assume collinear points. We can assume coplanar points. Again, these are definitions. We can assume opposite rays. And we can assume intersections by looking at them. So again, collinear, coplanar, opposite rays, linear pair, supplementary, those are all definitions that we could assume. All right, so now let's go back to this diagram and talk about what can we not assume, okay? Because there's lots of things that we cannot assume in geometry. Okay? So first, I see line CB, and then BD, okay? I cannot assume that CB is congruent to BD, right? There's no tick marks, so I cannot assume that. I also cannot assume that line CB is perpendicular to line AB. We can never, ever, ever, ever assume right angles. They have to be marked for us to assume or to know a right angle. Along with that, I can never assume acute or obtuse angles. If they don't give me the actual measure of the angle, I cannot assume. I can't say, well, it looks like it's acute. We can't do that. Okay? We cannot assume perpendicular lines. So up here I was very specific, but overall we cannot assume perpendicular lines. We cannot assume parallel lines. We cannot assume 3 points being collinear. We cannot assume intersections. So if we don't physically see the intersection, we can't say, oh, I think if this continued on, it would intersect. We cannot assume bisectors or midpoints. So that gets us a pretty good list of things that we cannot assume. So let's try this. Right? We have this figure down here. Read the following statements and answer true or false. So number 1, ray EF, ray EA, and ray HE all share a common starting point. Okay, I didn't have to look at the picture to know that that is false. The first two share a common starting point because they both start at E. The last ray starts at H, so that is false. Remember that rays have to have the same starting point. Number 2, points F and H are collinear. I don't even have to look at the picture. Remember, collinear points, I only need 2, so this is true. Any 2 points are always collinear, right? Three, points H, D, and C are coplanar, okay? So I need to look at my picture and make sure that they're not all three on the same line. H, D, and C. Yes, that is true. That would actually be the front of the box. Okay. Let's see if I can make this writing look a little bit better. Number 4, points A, E, and G are collinear. I have to look at the picture because they gave me 3 points for collinear. So I need to make sure that they're all on the same line. A and E on the same line. Here's G. So that is false. 5, points D, A, F, and G are coplanar. Okay, again, I need to look at the picture. So I have points D, A, F, and G. Okay, they're not all collinear. So I look at the picture and I think, oh, well, they're not coplanar because they're not in the same plane. But remember, if I can make a plane out of them, can I make a plane that contains those 3 points? Or sorry, those 4 points. Yes, I can. Right there. It's that diagonal plane. So this is true. It is a plane that slices the box diagonally. Okay. Remember, the planes are kind of tricky to look at. Do I know that it's going to make a plane, therefore they're coplanar? All right, the intersection of plane EHFG. So EHFG. So that is EHFG. That's the bottom of the box. And plane FBCG. FBCG. That is the right-hand side. Is line FG. What do they have in common? This line down here. Yes, that is true. Okay. All right, so let's try this again. Okay. Section 2.4, part 2, tryouts. So they give me this picture. Write A for assume or NA for not assume. So by looking at the picture, only what they give to me, can I assume or not assume this? So line CE is perpendicular to line BD. Remember, I cannot assume perpendicular. The only way I know perpendicular for sure is if there's a right angle marked. Okay? So CE and BD, it has this right angle marked. So yes, I can assume that because it is marked as a right angle. That's the only reason I can assume that. All right, number 2, AC is equal to AE. Okay, so AC, okay, up here, and AE down there. I cannot assume that because there are no tick marks. It does not tell me that, so I cannot assume that. All right, number 3, segment AB is congruent to segment AD. AB and AD, yes, I can assume that. Am I writing back? I can assume that because it has tick marks. Number 4, angle BAD is a straight angle. Okay, BAD, it's a straight line. Yes, that's the definition of a straight angle. So yes, we can assume that. This is the definition of straight angle. Number 5, angle CAD is an obtuse angle. So I look at my picture, CAD, okay? I don't know that CAD is a obtuse angle. Remember, obtuse we cannot assume, so I cannot assume this. Number 6, angle BAE is a right angle. BAE is a right angle. It is not marked a right angle, but because this one is, and by my definition of straight line, I know it has to be 180 degrees or a linear pair. So BAE, I know by definition that one would have to be a right angle. So I can assume that because angle CAB is marked 90. That's the only reason I can assume that right there. The last one, ray AC is opposite ray to AE. AC opposite to AE, yes. I can assume that again because that is the definition of opposite rays. Right? So that is a quick glance at day 2, what we can assume and not assume by looking at diagrams.